Hello everybody, welcome to my channel algonexus. So in this video, I am going to solve the Leedcode question which is palindrome number. Okay, so first let's read the question. Here, given an integer x, return true if x is a palindrome and false otherwise. It means the given an integer x, okay, here given an integer x, if x is a palindrome number, yeah, then we have to return true. Otherwise, if otherwise we have to return false. Means if x is not a palindrome number, we have to return false. Okay. So first, let me explain you what is palindrome. Okay. Then see what is palindrome. Consider this is a number, digit. See this is a number 1, 2, 3, 2, 1. Okay. So while reading, we read from left to right, left to right. Okay. Then what is palindrome? Normally we read left to right. Okay, just start reading from right to left. Right to left. What it will be? When we start reading from right to left, it will be 1, 2, 3, 2, 1. So this is what? Right to left. We read from right to left. So let's consider if this number, this number, and this number, yes, both are equal. Means if we read from left to right and also read from right to left, the meaning are same, the number is same. So what does it mean? So this is mean this number is palindrome. This number is palindrome number. Okay, understand what is palindrome number? So let's consider the another example. See, let me write here. So this is example 1 and let me write example 2 here. See what will happen if I take the example 1, 2, 3, 4, 1. Okay, just read left to right, left to right, left to right. So what is here? If we read the left to right 1, 2, 3, 4, 1. But when we start reading from right to left, right to left, what it will be the? If we start reading from right to left, see first number, first digit is from here 1. I will write 1 here. Then 4, here 4 I will write. Here is 3. I will write here 3. Then 2. I will write 2 here. Then 1. What happens here? Hmm? See, when I read from left to right, the number is 1, 3, 4, 1, 2, 3, 4, 1. But when I read from right to left, reverse form, in reverse form, I will read 1, 4, 3, 2, 1. But at the finally, these two number is not equal. See, 1, 2, 3, 4, 5. If I read reverse, the number will become 1, 3, 4, 2, 1. This both number, while reversing the number, these both number are not equal. So what does it mean? This means this number, this number is not palindrome. Okay, this number is not palindrome. Understand what is the meaning of palindrome and which number is not palindrome? See, let's take the another example. Let's take here example 3. Okay, let's take example 3 here. Oh, sorry. Let's take the another example. Okay, if I take the example, see, minus 1, 2, 3, 2, 1. Okay, if I take the minus 1 3 2 1 2 3 2 1, when I will read from left to right, what will be the number? How you will read minus 1 2 3 2 1? But when I reverse the number, when I reverse the number, then what will be the number? When I read the number from right to left, the number will be 1 2 3 2 1 and minus. But what's happened here? Here, this number will not a palindrome. Okay, let's see here at example 1. At example 1 here, what happened here? I took the same number 1 2 3 2 1 1 2 3 means 1 2 3 2 1 and read reverse form. In reverse from right to left, the number is become 1 2 3 2 1, same only. But at third example I just put a minus. So see, minus 1 2 3 2 1, and reversing the number while reversing the number, it's becoming positive. Okay, the the number is same, but the what's happened here, the sign, it's getting different. Here the negative sign is there, means minus sign is there. While reversing the number, the minus sign is not here, means it's become positive number. Okay, so this is not a palindrome. Okay, so this number is not a palindrome number. Okay, its number is not palindrome. Okay, now let's take the example 4. Okay, just I'm writing here example 4. Now what will happen here? If I take the example for like number, not 1 0, let's take, yeah, 1 0, let's take 1 0. Okay, what will happen here? What it will happen here? If I read from left to right, then I will read 1 0. But if I read from right to left, if I read right to left, what will be the answer? 0 1. Okay, it is become 0 1. So it is also not a palindrome number. It is not equal to palindrome. Number is not a palindrome. Okay, got it? So now let's implement this. Okay, now let's implement this in Leedcode. Okay, so let's take an example of this. Let's me explain this here. 1 to 1. When we read from right to left, it will also become 1 to 1. See, 1 to 1 read as 1 to 1 from left to right and right to left. So it is palindrome. So now here minus 1 to 1 false. The output will be false because from left to right it read minus 1 to 1. From right to left it become 1 to 1 minus. See, there is not a palindrome. Got it? And what's happened here in example 3, input is 1 0. From we reading from 0 1 left to right, there is, it is basic one. Okay, so this is not a palindrome. So for this, to code, to implement this logic, so implement this code for palindrome number, what will be the logic? Okay, let's write here, see, let me write here, okay. So that is a explanation, this part is a explanation. Okay, let me write here explanation. This is the explanation of palindrome. Okay, explanation of palindrome. So let add down logic for palindrome. Okay, here I will write the logic for palindrome. Logic for palindrome. Okay, here I will write the logic for palindrome. So what will be the logic? What will be the logic? See what we have to write. Just if we are given the number num n, let's consider integer n is equal to 1 to 1 and 1 to 1, and we have to, means it is a given, the n is given, it is 1 to 1, and we have to create another variable, let's consider as n2, another variable, and from last side, means from right hand side of the number, means the digit, right digit, we have to first store in this here. After storing, we have to store this digit here. After storing, means after this we have to store this digit here. Okay, so means we have to create another variable n2, and the reverse number we have to store here. Okay, at the end we have to store here. So this is a first method. No, not first method. This is a first part what we have to do. And second, what we have to do at second, if the number is negative, if if n is negative, so definitely the negative number will not palindrome. If the number is negative, the negative number will not palindrome. How? How? So let's go upward. Okay, let's go upward. See here in example 3, any number, if I take the negative, okay, any number if I take the negative, but at the end, at the reversing the number, what happened? The negative will come at the right hand side, means at the right hand side of that reverse. Got it? So definitely, if we reverse the number, the here we will get the positive one. Means default it will be positive. So it is basically what, if we take the negative number, that means the number is not a palindrome. Okay, just keep in mind, if we have to check the palindrome of a negative number, just directly write if we got a negative number. So what does it mean? We does not have to check. We does not have to reverse the number. If there is a negative sign in a number, we does not need to reverse the number. If the negative is there, this does mean it is not a palindrome. Okay, because palindrome, if we reverse the negative number, the negative number will always come in this last digit. Okay, in this last digit. Okay, so let's write here palindrome. Okay, so second one is this, and what will be third one? At the last, at the last, okay, at the last, we have to check n number is equal to n2. Okay, if n, this n, the given n is equal to n2, means what? Yeah, the condition will be true. It is palindrome. Okay, what will happen? Then it is palindrome. We have to check. Got it? We have to check the statement. Okay, if otherwise, if else condition, what will happen? If else condition, if there is, we have to, this condition we have to put in the if statement. In what is third? Third, we have to write, we have to compare n is equal to n2. If it is true, palindrome, otherwise it will be false. If it is not equal, then not palindrome. Okay, got it? So this is a three, means the three method. No, method means not a function. Okay, in Java, function means method. So I just want to say we have to implement these three technique or three method to solve the palindrome. Okay, so let's me write here something. First method should be, so this, if we want to check the number is positive or negative. Okay, if number is smaller than positive, first of all we will write this one. Okay, this here in if condition. First we'll implement this one. Okay, first we will implement this one, then second we will implement this one, and third we will implement this one. Okay, because first of all we have to implement this first one. Because first of all we have to check if n is negative or not. If at the end we got to know that after the all the processing, reversing the number. Okay, so time complexity will be more. So this first technique, okay, this is called reversing the number. Reverse of a number. Okay, here we are this, and while reading, okay, this is a reversing the number. So let's start implementation. And again one more thing, the fourth one. Okay, see what's happened here. Okay, let me, I will explain in here. Mm, while doing the code you will not understand here. Okay, so what is for what first we have to do? The first we have to do if number is negative. Okay, let's do the implementation right here. If 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 x is smaller than 0, that means of course it is a negative number. It is negative number. So return RUT and return false. Okay, first method is over. So now let's reverse the law, reverse the number. So what will the logic for the reversing the number? Okay, let me write down here. Reverse the number. Okay, I will write here logic for reverse the number. Okay, so what will be the logic for reverse the number? See, let's consider number n is 1 to 1. Okay, let's take it. This is a given. This is a given part. Okay, it is a given part uh, by the code, means by the question. So what will happen here now? So this is not equal to wait. This is a given part. Okay, this is a given part. We will use a while loop here. Okay, first of all we will use while loop. In while loop, what we will do here, n not equal to 0, the first condition. This is the first condition. Okay, this is our first condition. Now after that, inside the curly bracket we will write, let here we have to initialize first reminder. See what happened. First of all, let we initialize int initialize int reverse. Okay, because we want to reverse this digit, we have to put in this new variable. Let's consider the new variable is reverse. Here what we have to do, first of all we have to add one last digit of n, last digit of n. Okay, one should be there. So for this logic will be, See, what will be the logic here? If we want, see, so this is a number, 1, 2, 1. First of all, we need this number. So from 1 to 1 number, I want last digit number. Okay, so what should I do? What should I do? See, there is a mod in Java. So if I do like 1 to 1 divided by 10, mod 10. What does it mod means? See, let's first explain mod. Mod operator is give the remainder. Okay, remainder. It's give the remainder. Okay, see how what's happened. If I want to add, no, if I want to divide the number like 4 divided by 2, what will be the output here? 2. Okay, if I let's consider if I want to divide 3, not 3, okay, let's take 7. 7 divided by 2. Now what will be the answer here? 7 divided by 2. Let's do here. See, 7. Here I will take 2. Let's 7 3s are 6. Okay, 1. So what will be here? This is 6. So here will be 3. Okay, but see, we divisible by 2. By dividing, we get this number, that 3 1. But if you want reminder 1, I want this reminder 1. So what we'll have to do? What I have to do? Just do it 7 mod 2. Okay, just do the 7 mod 2. It will give 1. Means mod means it is mainly used for remainder. If we doing the 7 divided by 2, there will be one type of remainder. So mod it display means only take the remainder. Okay, if what will happen if I do here, if I do what, if I do here 7 divided by 2. So if I do 7 mod 2 here, let me write perfectly. If I here write 4 mod 2, what will the answer now? See, 4, 4, 2, 2, 2, 0. 2 into 2, I will get 4, of course 0. So here is mod. Mod will give remainder. So now what is our current remainder here? The current remainder is 0. So this is how the mod operator work. So this is how our mod operator work. Got it? Okay. This is how a mod operator work. Let me remove this. Let me remove this. Okay. Inside I am put here. Okay. I am putting here. Okay. Just because I need this space for writing. Okay. Let's continue us. So what we have to do? This is a n is 1 to 1. I need the last digit. Last digit. So what we have to do? Let's take a variable r. R is for remainder. So see here. I want if see if I divide 1 to 1 by 10. Of course, what will be the answer? 10 into 12, we get 120. What will be the remainder? 1. What is 1? 1 is a last digit of 1 to 1. Got it? So what we have to do? Let's take a remainder variable r. I will write here r. R is equal to 1 to 1. This is 1 to 1 is what? N. N mod 10. What is n mod 10? 1 to 1 mod 10. I get 1. So 1 will be here. Okay. The currently I will declare r is equal to 0. Rev reverse is equal to 0. So now what will happen? See, At the, this is our what? This is our first line and second line. See, what will be our second line? After that, what we have to do? Take REV variable. Now, currently, what is REV variable? REV variable is REV variable is 0. So I will write this logic: REV multiply by 10 plus remainder. See, let me explain this. Let me explain this. Okay. Let me explain this, the second line. So what is actual happening here? See, what is happening here? Now let's take, I am first I do the remainder of 1 to 1 mod 10. 1 to 1 mod 10. Okay, I get 1, I put here 1. Okay. And in another while loop, what I will do, if, let's consider, I got a 12, so I need this 12 now 2, because from the reversing form the 2 is a second digit, so I need 2. But to bring this 2 here, okay, let's consider I got a R. Now let's consider the second digit, the second remainder is 2. Let's consider, I will explain you later how 2 come here later. Okay, let's consider R is 2 now, but to put in the ones place. Okay, what will happen here? This is 1 place, this is 10 place. See what is there in digit. This is 100 place. Okay, 100 place, and this is 10th place, and this is ones place. No, that, okay, okay, wait a minute, let me check, let me check. Digit place in number. Okay, digit place in number. Let's check what will happen here. Just want to see that table. Yeah, see, this is table. See, once, see here what is happen. Let me open this. Not, I want open image in new tab. Yeah, see here what is here. See, the second is once, that fifth is 10th, and H is 100. What we have to do here? If we want this 5 in 10th place, we have to into 10. This is ones, twos, 3. Let me explain properly. Let me explain you properly. See, what's happened after reversing the number. What will be the our reverse number? 1, 2, 1. Currently, I got 1. Okay, but 1 is a in ones place. Ones place means this is 1 place. Ones place. Okay, see, after reversing the number 1 2 1, 1 to 1. Okay, okay, this is table of that digit. Ones place, 10th place, and 100 place. Means how we will read 121. Okay, but I got this reverse while reading from left to right, right to left. The 1 should be in the 100 place, but currently here 1 is in ones place. But to convert this 1 into 10 place, then 100 place, first of all we have to multiply by 10. After multiply by 10, what's happened? It's come in a 10th place. Okay, 1 become 10th place. Now add the remainder here, 2. Now what will happen? 12 is there. Okay, 12 is there. So now what will happen at the end? At the end here, remainder will be 1. What will the, after third loop, I will get this number. Become first loop, I have to take this number. In second loop, I have to take this number for reverse the number, and for the last loop, in the last loop, I have to take this number. So now what will the current remainder? 1. So now what we have to do? Again, we have to transfer this 10th place into 100 place, ones place into 10th place, and current digit, current remainder we have to put in the ones place. So again we have to, what we will do? we will do 12 into 10. It will become 120 plus remainder r. R means 1. Now it become 121. Which now it is in current place 1 2 1 1 to 1. Okay, let's do it. Okay, let's do it. Let me remove this. Okay, remove this at the side. Okay, let me rough. Okay, see, this is our second line which is used for to convert the tenses, means convert the places of the digit. Okay, and third, what happened at the third line? In third line, we have to write n is equal to n divided by 10. Now loop will complete it. And for this 10, we have to remove the last digit because this last digit we are placed in the reverse one. Okay, let's do it. Let's do it properly. Okay, let's do it properly. Let me rub this. Okay, okay. See, this is our main logic. This is while loop one main logic. Okay, first is for reminder, second is for converting the places of the digit, and third is for divide the 10 because we need that third line is for to reduce the number last digit number because we are reading from right to left. Okay, see, let's consider now what we will given. It will be given n is equal to 1 2 3 2 1. Let's consider now this is a number. Okay, what we have to initialize first, we have to initialize r is equal to 0 at the current, and this is our n. Okay, don't forget this is our n. And at the last we have to what we have to initialize 0 and declare as 0. Okay, see, now let's do one by one. Let's do it. Okay, see, let me take 3. It will visible. Yeah, it is visible. Yeah, see. Okay, so now let's start it. See, when compiler enter in the while loop, first it will check the condition. What will the condition? N is not equal to 0. Now what is the current value of n? 1 2 3 2 1. Yeah, condition is true, which means the n is not equal to 0. The condition is true, the compiler will go inside this and it will execute the first line. Okay, in executing the first line, what is happening here? See, n mod 10. So let's do the roughly here. N mod 10. What is n? 1 2 3 2 1 mod 10. What will be the answer? What is meaning of mod? Mod means it will give the remainder. First of all, it will divide n divide by 10, and after at the end it will return the remainder. See, let's formula 1 into 1, 10 ones are 10, remainder is 2, means remaining 2, the 3 will come here, 2, it will give 20. Okay, 3 will come here, again 2 will come here. Now what will happen? 3 30, 2 will come here, 1 2, what's happened here? 10 twos are 20. Now remainder is 1. Okay, in r value now the remainder is 1. Okay, remainder is 1. Understood? Now currently what happened? The remainder is 1. Now what will happen here? In it now compiler compile the first line, then it will next line, then it will jump to the next line. The next line is rev, that reserve. Now currently is reserve. Let's consider that REV here. See, this line I am writing here again. REV, REV into 10 plus R. Okay, this is our second line. What will happening here in this second line? Current value is 0. Okay, current REV is 0. Okay, the current REV is 0 into 10 plus what is the current value of in R? 1. So now let's consider, so sorry, this is REV. Okay, REV. So now let's, what will happen? REV equal to, what will this? 0 into 10. Of course, answer will be 0. 0 into 10, 0 plus 1, 1. Now REV is become 1. Let's write here. Let's write here 1. Okay. Now compiler will, after executing this second line, it will jump to the third line. Okay. So what will happen? After second line executed, it will jump to the third line here. N divided by 10. Okay, n divided by 10. So this is, okay, this is n divided by 10. This is n divided by 10. Okay, so what will happen here? See what will happen here. Here what is n is, now n is 1 2 1 2 1. This is 1 2 1 2 1. Okay, let's divide by 10. Let's we divide by 10. What will be the answer here? Remainder will be 1, but 1 2 3 2 1. The answer will be 1 2 3 2 1, because we, when we divide n divided by 10, it will return this value. Okay, it will return this value, not reminder. Okay, now what will be the current value of n? Now the current value of n is 1 2 3 2 1. So what does it mean? What does it mean? Okay, it means that it, at the number, the last digit of number got removed. Okay, last digit of number got get. First of all, previously what was our n? 1 2 3 2 1, and after dividing n divided by 10, so the last digit, our last digit got removed. Okay, now the what is our current number here? What is our current number in n? 1 2 3 2 1. Sorry, 1 2 3 2. Okay, at the fourth, the compiler will again jump to the while loop. Now it will check again, n is not equal to 0. Yes, condition is true. N is not equal to 0. Again it will jump to the first line. What happened in first line? Again it will uh, find new reminder. Again it will find new reminder. So now currently what happened? See, now currently new n is 1 2 3 2. Okay, new n 1 3 3 2. We have to do mod 10. Again we have to divide this. What will be the answer? 10 into 1, it will get 10. Reminder 2. 10 in, then 3 will come here. 10 into 2, it will give 20, minus reminder 3, 2 will come here. 10 into 3, it will become 30, reminder 2. Okay, so now what will be the current value of R here? Here will be 2. Okay, here will be 2. Let's remove it. Here will be 2. Okay, so now what happened? It will jump to the second line. It will jump to the, after executing first line, it will compile jump to the second line. So let's do rough here. Okay, now what is our current REV value? 1. So let's write here 1 into 10 plus what is our current R? 2. Let's write 2 here. Got it? And while calculating this, what will be the answer? 1 into 10, 10 plus 2, it will give 12. Okay, means now currently, now our REV reverse number become 12. Means what happened? The last digit of this number enter in the REV. Okay, the last digit of this number enter in the REV. And in the third step, we have to cancel, means we have to remove, we have to delete, we have to remove this last digit of n. So for this, we are doing this third statement. Okay, so we have to execute this third statement. So after this completing the second statement, the compiler will jump to the third one. Now what will the answer? N divided by 10, 1 2 3 2, 1 2 3 2 divided by 10, answer will be now 1 2 3. So now the current will here 1 2 3. Okay, got it. Now here 1 2 3. Again here what will happen here the compiler will again jump to the while loop. Okay, now current it will check the condition n not equal to 0. Yes, condition 2, it will jump to the first statement. It will give the remainder of 1 2 3 2, sorry, 1 2 3 divided by 10. Definitely while doing the mod, the answer will be 3. Okay, then now the current value here current value will be 3. Okay, now next what happened? The compiler will jump to the second line. Okay, here what will happen? This line will execute, which is I wrote it here. Okay, so now execute this line. Now the what is our current value of REV? What is current value of REV? Okay, current value of R is 12. Let's write here 12 into 10. This is into 10 into what is current value of R? 3. I will write 3 here. So here 120 plus 3 equal to 123. Okay, what's happened here? Now what happened here? The current value of REV is 3. That means the last digit of n is when gone to the REV in last digit. So after executing this, we have to the compiler will jump to the third line. Okay, it will execute this line of code. So after executing this line of code, what will the answer? Like 1 n divided by 10. So the answer will be 10 1 2 3 2, sorry, the 1 2 3 divided by 10. What will be the answer? The last digit of n will remove. Okay, while dividing. So what is our current value in n? Our current value of n is 12. Okay, now again what will happen? After completing this third line, the compiler will jump to the again while loop again execute this condition. Now the condition what? N not equal to 0. Yes, condition is true because now currently n is 12 and which is not equal to 0. Okay, not equal to 0. Again the condition is true. The compiler will jump inside in the first condition, first statement. Here what will happen? R is there, reminder. What will happen? It will divide n mod 10. Okay, what compiler will do? N mod 10, which is what is n now? 12. Mod 12 is there and 12 mod 10. Okay, it will do 12 mod 10 means 12 mod 10 definitely now, sorry, 12 mod 10, it will give last digit of this n, last digit of it 10. Okay, got it. So what will be the remainder now? It will be current remainder will be now 2. Okay, after executing this line, the compiler will jump to the second line. Okay, now current value of REV. Okay, I'm going to write here. Now the what happened? The current value. What is the current value of REV? Current value of REV is 1 2 3. Let's write 1 2 3 into 10 plus R. What is R here? Now the R is 12, means 2. Let's write 1 2 3 into 10. Sorry, 1 2 3 into 10. It will give 1 2 3 0. 1 2 3 0 plus 2. It will give 1 2 3 2. Okay. What does it mean? What does it mean? The last digit of n, this 2 will jump here, means remove from here and it will add to the REV. Got it? It will add to the REV. So the current value of 1 means sorry, the current value of this REV is 1232. Got it? The current value of REV is 1232. So now what happened after executing this line? The compiler, sorry, after executing second line, the compiler jumped to the third statement. In third statement, this line of code will run. Now what is the current value of n? N is 12. 12 divided by 10. What will be the answer? Answer will be 1. Okay, answer will be 1. So now here n will become 1. Now after executing this third line, the compiler, there is no other statement, the compiler directly jump to the while loop again. Again here what will happen? Compiler check this condition. Okay, here what is n now? 1, which is not equal to 0. The condition will be true. After that what will happen? Compiler go inside the while loop. Compiler go inside the while loop. While loop means the first statement. Okay, here what is our first statement? We have to find the remainder of n. So now current value of n is 1 mod 10. What will the remainder? Of course, remainder will be 1. Okay, see, of course, remainder will be 1. See, 1 mod 10. 1 zeros are 10 zeros are 0. Of course, then what will the remainder? 1. Got it? What will the remainder here? 1. Okay, so now here R will contain, okay, here R will contain, wait a minute, yeah, okay, here R will contain 1. Okay, after that what will happen? The compiler completing the first statement, it will jump to the second line, and now it will execute the second line. Okay, it will execute the second statement. So what is our second statement? What is our current REV? REV is 1232. Okay, 1232 into 10 plus what is our current R? 1. So 12320, the tenses means the place of the digit change. Now plus 1, it will become 12321. Okay, so now what will become? REV 12321, and after compiler this first one, it will jump to the third statement. In third statement, n divided by 10. So what is current n? N divided by 10, we will get of course 0. N divided by 10, zeros are 0, 1. Okay, so here after doing n divided by 10, the answer will be here 0. Okay, answer will be here 0. N will become 0. N will become 0. Got it? So after completing this third statement, the compiler again jump to the while statement. Okay, it will check this condition here. Okay, what will the condition now? 0 not equal to 0. Condition is now false. So now the condition is false means the compiler will not go inside this while loop. It will directly execute the remaining code after the while loop. Okay, got it? Got it? So this is how our logic for the reverse the number. This is how for the logic for the reverse the number. Okay. So now what happened at the end? So this is what happened here. So see here in first case, let me write properly. Let me write properly here. Okay. Answer will be 12321. Okay. And let me remove this means I just want to do side. Okay. Of means there is a lot of are available. Ah, okay. Just I have done the side. So here what happened? Okay. Here what happened now? See, let me explain again. Take a revision. The first step is for, okay. This step is for that first line. first statement is for to return the last digit of number. Okay, and logic means second statement is for to change the places of digit change the places of digit in number. Okay, and third logic is for the third statement is for to remove the last digit from given number. Okay, for given number. Okay, this understood? So this I just write it here. Okay, so now what will happen after completing this? Okay, after completing this, what is our third one? We have to compare n is equal to n2. Okay, at the place of n2 we have taken here, means at the place of n2 we have taken rev. Okay, means rev means reverse variable. We means just change the name of the variable. Okay, so what will happen after completing this? We have to compare the variables. So now in if condition we have to check. Okay, if in condition we have to check here if rev equal to n, rev equal to n, what will happen? What will happen? The it will if rev equal to n means reverse number is equal to the previous number, it will be written true, means it is palindrome. So we will write return true. Okay. Else in else part what will run? Definitely the it is not a palindrome. It's not a palindrome. Okay, it is not a palindrome, so we will return here false. So we will return here false. So we will return here false. Okay, understood? At the end, just we have to check the condition. So this is our logic for palindrome. Okay, but let's see what will happen now. Okay, so okay, see here at the end what happened here number becomes 0. Okay, so now what will happen at the end we have to check the condition. Okay, we have to check the condition rev. What is our current rev? What is our current rev? Yeah, our current rev is 1 2 3 2 1. Here should be 1 1 2 3 2 1. Okay, I will write here 1 2 3 2 1. But what now while comparing this with n, what is our current n? But actually what happened? Our current n is become 0. Okay, 0. So definitely in this condition the condition will be false. Definitely the condition will be false. Okay, then of course it will directly jump to the else part. Got it? Directly jump to the else part. So what we should do before writing this code, first of all we will initialize means we will initialize one another variable. Let's initialize another variable here. Org means let's consider original value. The name is original value. First of all, we need to transfer the n value at the starting of the starting means before executing the all the code. First of all, what will be the our n value, like 1 2 3 2 1 was our n value. First of all we will transfer to the original variable means another variable 1 2 3 2 1. Okay, after executing this three step, after executing the while loop, of course what will happen, the n's value of the n's will become 0. Value of the n's becomes 0. So before checking the condition, Okay, wait a minute. Let me write properly. So before, okay, before checking this condition, okay, this condition statement, first of all, we will transfer the org, means original number, into n. We will transfer the original number into n. Okay. Now after that, we will run this if statement. So now what will happen after transferring this original value into n? The here what will happen? Here 0 will be removed. Okay. Now the current value will be 12321. 12321. So now it will check. The reverse number is 12321, which is this is the reverse number, and the n number, this 12321. 12321. What will happen here? What will happen here? The condition is true. It will means it is a palindrome. Okay, understood? So what will be the logic? In here, three step is very important. First step is for reduce the means three step means see here three logic is very important. First of all, we have to reverse the number, and second logic, if the number is negative, directly written as a fall, means it's not a palindrome. And third, we have to at the end, so we have to check this condition. So from this, first of all, we have to write the logic for the negative number, and then we have to write the reverse number. Then after at the end, we have to write the palindrome number. Okay. So this is a logic for palindrome. And at the reversing reversing the digit, what will be our three logic, three statement for reversing the digit? The three statement are: first statement is to return the last digit of the number, return the last digit of this number. Okay. And second statement for return the no, sorry, to change the place of the digit in number, to change the place of the digit is number. If the 1 2 is given, so we have to, this is ones place, this is 10th place. If we want to convert this 10th place, means places of this digit, so what we will do, we will just into 10 it, so it will become 120, means that 10th place become 100. Okay. Ones place become 10th, and 0 will be add here. Okay. So this is how to change the logic for this sentence. Okay. This logic, this numerical, this formula is for to change the places, 10 places, means places of the digit. Okay. At the end, to remove the last digit of original number, means the given number, to remove the last digit of the original number, means what happened here? Here last digit is added, the original numbers last digit is added in the reminder, and from end the last digit will be removed it. Okay. So this will be the logic. So what's happened here? So I am highlighting this. Okay, I am highlighting this because it is very important. This okay, this logic is very important for reversing the number. Why I am taking this very important? Why I am writing here very important? Because there are so many questions, we will use this logic. Okay, we will use this logic. So it is very IMP. This logic is very IMP. Okay, understood? Let me remove this rough one. Okay, so okay, so understand. So this I taken the example one. So let's quickly revise this logic with the another example. Okay, quickly revise the logic with another example. Okay, let's take here example 2, and I will take here example that given number will be n is equal to 1 2 3. Let's take a small example. Okay, so first of all, what we have to do? First of all, we have to do initialize the original variable. Let me do it with the pink pen. We have to initialize the original variable. Okay, in original variable we have to declare as n. Means what will happen here? Original value become 1 2 3. After that, what we have to do? Initialize reminder r and declare as 0, and initialize another variable as name as reverse number and declare as 0. Okay, let me copy paste that this logic. Let me copy paste this logic. Okay, let me copy paste this logic here. Okay, let me copy paste this logic. Let me paste it. Okay, this is our logic. Okay, this is our logic. Okay, so in a fast way, I'm going to explain this. I'm not taking long time here. Okay, so what happened? This is our first statement. This is our second statement, and this is our third statement. Okay, let's quickly revise. Quickly revise the concept of this. First of all, what will our logic? First of all, before doing this logic, we will write the if condition is negative. If the condition is negative, this value is not run. It will return false. First, it is positive number means it will jump to the while loop. In while loop, what is 1 to 1? N is 1 to 3. Now current n is now 1 2 3. Okay, and it is not equal to 0. Not equal to 0. Okay, the condition is true. Now compiler go to the first statement here. Now it will run the, it will give the remainder of 1 2 3, remainder of n, remainder of n. So what will the remainder of at 12? So 1 2 3 mod 10, it will give 3. Okay, it will give 3 here. Okay, so let r is equal to 3. Here r is equal to 3. Okay, now what happened in, now after that compiler will jump to the second statement. Here second statement, I am right here rev 10 plus r. Here what will the rev? Rev is 0. What will be our 10 plus what will be our r? 3. Okay, this r. So what will the answer? 3. The current value of the rev is 3. Okay, after that, after compiling this, the compiler jump to the third statement, which n divided by 10. So n divided by 10 is 1 2 3 divided by 10. It will give, it will remove the last digit of that n. Okay, now the current value of n is 12. Current value is 12. So after that, compiler will jump to this here. Now it will check the r again. What will the remainder of 1 2? It will give the 2. Okay, it will give the 2. Okay, it will give the 2. Now after 2, the compiler will jump to this line. It will calculate this. Okay, it will calculate this. So what will happen here? What is current rev? Rev is 2 into 10 plus what is r current 2? Sorry, current rev is 3. Sorry, current rev is 3 into 10 into 2. Now what will be here? 30 plus 2 become 32. So what will be the current rev? Rev become 32. So now after this, the compiler will jump to the third statement. Here statement n divided by 10. N divided by 10 means now n divided by 10 is now currently value of n will become 1. After 1, after compiler this, the compiler will jump to the again while loop. Okay, while loop. Here what will happen? Condition will be checked. Here what is n, which is not equal to 0. Yes, condition is true. Condition is true. What will happen now? It will jump to the first statement where we have to check the remainder. Now if I do 1 mod 10, definitely it will give reminder 1. Okay, definitely it will give reminder 1. Okay, so now the current rev, sorry, not rev, current reminder is 1. Okay, now the current reminder is 1. Now after executing, it will jump to the second statement. What is second statement here? Okay, here current statement is rev is now 32 into 10 plus 1. So it will become 320 plus 1, 321. Okay, now current rev, the current rev, this one is now become 321. In after that, completing the second statement, the compiler will jump to the third statement. What is n divided by 10? What is current n? N is 1. Current n here, current n is 1. 1 divided by 10, it will give 0. Definitely it will give 0. Okay, it will give 0. So the current value of n will become 0. So what will happen again after executing the third statement? Compiler jump to the while loop. In while loop, what will happen? 0, n is currently 0, not equal to 0, means condition is false. So after that, it will not execute this line, it will execute the remaining code which is written after the while loop. But what we have, what we will do here, after the while loop completing, means after the reversing the number, means the reverse logic will completed. What we have to do? We have to do n is equal to org, because now current value of n is 0. Okay, current value of a is 0. If we compare the current value n equal to rev, so definitely condition will fall, because current value of a 0 is n, current value of n is 0, and if we compare 3 to 1, definitely it will be the fall. Definitely it will be the fall. 2 means, so we have to convert means change the value of n. Okay, so we have to change the value of n. So that's why before I have stored the, I have here org, I have stored the current number, current value, means I have stored the given number before itself in the org variable, in the org variable. So our org variable is 1 2 3, so it will go to the n 1 2 3. Okay, now our current variable value of n is 1 2 3, so now it will be check 1 2 3. Okay, now after that, what will happen in this condition? It will condition the current value of n will 1 2 3. So what will happen? So now see, the original number, means the original given number n is 1 2 3, which is not equal to 3 to 1, means this is not a palindrome. Okay, see, what is palindrome? The given number is 1 2 3. So if we read from right to left, it will be 3 to 1. Okay, so what happened? 3 to 1 is reverse, and current is 1 to 3. So of course this is not a palindrome. So for this example 2, the answer will be, the answer will be not palindrome, not palindrome, not palindrome. Okay, this is the answer for the second example. So let's implement this in the Leedcode. Okay, let's implement this. For first negative number, we have taken this. So before this, first of all, we will let's do bigger. Okay, bigger the code. Okay, first of all, I will take here int r is equal to 0 for remainder. Okay, let's take int rev for revision, sorry, for reverse the number is 0. And after that, what we have to, take the another variable like original number org to store the original number x into org variable. So after that, we will not get any type of error. So first, what was our first here? So here, what was our first? See, first of all, here, see, here, first of all, we have to write this negative number. We have written after the negative number condition, while checking the condition, we have to write this second one. So what is second one? To reverse the number. Okay, logic for the reverse the number. See, so we will write here logic for the reverse the number. See, we can write this reverse the number in else also, right? Else statement also. Okay, so means I want to say that we can write this reverse logic in else part also. Okay, and if we not write in the else part and directly write here, it is also possible. Okay, we can do both of this. Okay, so let's write the logic for the reverse the number. Let's n not equal to 0. Okay, after that, what happen? R is equal to, we have to take a remainder of x. X is a number here, x is a number. Okay, So we have to take a remainder here, x mod 10, we get a remainder in R. Now what we have to logic for, what have the logic to change the digits place. So this logic for is rev is equal to rev into 10 plus 10. Sorry, it's plus R. So this is the formula. This is a formula which is very, very important formula for reverse the, means sorry, not reverse, please, means transfer the digit into tenses, increment higher tenses. Okay. After that, what will happen here? We have to remove the last digit of the original number. So we will take n is equal to n divided by 10. Sorry, not n. We are original number taken in the x form, x variable. X is equal to x divided by 10. Over. Okay. So again I am repeating this statement. This line is for to get last digit of x number. Okay, and this logic for to change to change the places of digit. Okay, and this logic for to remove the last digit of x, means the original, the given number. Remove the last digit of given x. Let's write here given x. Okay, given x. Okay, here to get the last digit of given x. Okay, of what I am writing here, given x. Okay, let's, and at the end, after that loop, what we have to write? We have to store that n, means n is equal to org, original number we have to store in the x, not sorry, n, not here, we have to write x. Okay, after that we have to check the condition. If rev equal to x, rev equal to x, it means it is a palindrome. So return true, true. Otherwise, after that, okay, after that, in else part, we will write return false. Okay. So this is our logic. This is our logic. Okay. Let's run it. Let's run it. Let's run it. Yeah. Okay. I did not put this column where 20. Add the 20 or 28. See, yeah, 20. Okay. Sorry. So let's run it. Let's run it. What will be the test case of what happened? Illegals at 28. Okay. Extra did I put? Okay. Okay. Let's check it. Let's check it. What will the output test? What happened? Oh, sorry. Because while explaining, I took the n number. So actually there should be the x because the given variable is x. Okay. While explaining, I took the given number in a n variable. So that's why. Okay, let's check it. So definitely now the answer should be true. Yeah, see, accepted. Case one, what was our number? 1 to 1. Output is true. Okay. Read at the last reverse form, right to left, 1 to 1. In test case, see, if the minus number is there, let's consider as it is not a palindrome. Okay. After the reversing, it will become positive. Okay. 10, definitely 1 0. Reverse it, 0 1. Definitely it will be the fall. So let's submit it. Let's submit. Okay, see, 4 ms and 100% beat. Okay, okay. So now let's check the time complexity for this. Let's check the time complexity. Let's discuss about the time complexity here. Okay, let's discuss here time complexity and space complexity. Okay, let me make a line, perfect line here. Okay, so time complexity and and space complexity. Okay, what will be the time complexity as well as space complexity? So what's okay? What we will see the logic here first. Here, what will be the time complexity? What will be the time complexity here? See, in this question, see here, in this logic, if statement is there, and what we are doing, while loop, and there is no further loop. So what will be the time complexity? Yeah, what will be the time complexity? Yeah, what will be the time complexity here? So here, time complexity here means here time complexity will be 0 of n. But how 0 of n? Means sorry, 0 of x, 0 of x. But how? How it will be 0 of x? See, let me write here. See, because x, let's consider as x is a number of digit, total number of digit in a number. Let's consider x is a number of digit in number. See, if the total number of digit is 2, in what happened in the in C in this test case, what we are written? Okay, how many digit are there in x? 1, 2, 1. Three digit, total number of digit. So how many times the loop will be there? 3 times. Okay. So it depend on the number of digit. Okay, so here in second case, how many loop will be there? 3, because it consider 3. In third case, how many loop will be there here? 2, because in x number there is only 2 digit. So what will happen here? What will happen here? The time complexity here, time complexity is omega x. We will consider x. Okay, x. Why? Because in previous example means in Leedcode we have taken the n in sorry x variable was meant, so we can write xn also. Okay, no problem. So why time complexity x? Because because digit means x is a number of digit, the number of digit. X means see x omega n, so omega x is a time complexity, so x is a number of digit. Okay, let's consider x is a, what is x? X is a number of number of digit in given number. Okay, x is a number of digit in a given number, so time complexity here will be 0 omega of x. Okay, then what will be the space complexity? What will be the space complexity here? See what happened here, we created this variable rev variable, and org means original, to store the original x here, to rev to store the reverse number, and r to store the remainder of the number. So what will be the storage? See, the if we declare the variable, we creating the variable, it means it is taking some amount of storage from here, means where amount of storage from RAM or storage whatever. Okay, but the amount of this variable is very negligible, but still we consider as here time complexity. Sorry, not time complexity, here space complexity. Here space of, let me take different color. Space complexity is omega of n, 1, omega of 1. Okay, why omega of n? Because we consider as, means as as we as we are using a constant, means const amount of of extra space. Okay, we are using the variable like r, which is constant, and rev, which is constant, and org. For this we had space complexity O of, means omega of 1, which is very negligible. Okay, very negligible. So this is, so this is our space complexity and time complexity of our code. Okay, so this is a logic for our reverse the number. Let me write properly here. Logic for the reverse the number, and this is a logic for palindrome. Logic for palindrome. Okay, and this is the explanation, and this is our explanation with example. Okay, so had you understand? So this is how very simple the palindrome work. Okay, so the code for this, I will give. Okay, let me copy paste this. Control A, Control C, Google Doc, palindrome number. So this is our palindrome number code. So code, this is our code for palindrome. Okay, and I will share this file to you. Just go to my description and I will share the link to access this file. Okay, so you can access very well. And so now in this code, in this logic, there is no brute force and optimize for or brute force solution and optimize solution, mean brute force approach and optimize approach, because this code is very easy. Okay, for the beginner, they should know how to reverse the number. So this code is for the beginner one. Okay, so now, and even I'm giving this, attach this whiteboard. Okay, I will give link for this whiteboard also. Go to my description and there will be a link to access this whiteboard, so you can take the help of this. So for today's now, okay, so now this is the logic for the today's solution. So if you like the video, just click on the like button and subscribe to my channel, and share this video to your friends, so they also get help how to build the logic. And if you want to give any feedback on my channel for my teaching, means if you want to give the feedback of to my teaching. So just comment me down, and if you want to contact me personally, then in description I have the Telegram group of Telegram. Okay, means Telegram channel is there where you can join in my Telegram channel, and if also I also put my Gmail ID here. So if you want to personally contact me, so you can contact me through Gmail. So thank you for today.